Alright, so for this video we're going to be taking notes over pages 536 and 538, which was all about Earth's interior. So how do we know what the Earth's layers are made of and what they're like based on the information that we get from earthquake waves. So the last thing that we did in our notebook was the notes about seismometers and seismograms. So if you haven't done those notes yet, make sure you do those first. And then today is 19.2, still Earth's interior. All right, so we're going to do just kind of bullet point notes today. There was a lot of just straight up information in the part of the text that we read. So the first piece of information that we got from our text was that seismic waves pass through Earth's interior. And change speed or direction or both when they cross the boundaries between layers. Collecting data about where earthquake waves exit Earth is how we know about those layers. So we already know that the interior of the Earth is made of different layers, the inner core, the outer core, the upper and lower mantle. We talked about the lithosphere and the asthenosphere. We know all of those things because of earthquake waves and how they pass through the Earth differently and come out at different places. So what we're going to do next is write down how P waves and S waves are different in how they go through the Earth's interior. Slide the notebook up here. Okay, P waves first. P waves can go through the core but are refracted. Refracted is a word that means bent by it. So P waves can go through the core, but by changing from one material to another, so from changing from the mantle to the core, they are affected in their direction and in their speed. So they're refracted or they're bent by the core. And that causes a P wave shadow zone. So the P wave shadow zone is where no direct P waves exit Earth. And we saw that in the diagrams on page 537. You've got a worksheet that we're going to do here pretty soon that's got a picture of that on the front of it, and we're going to cut that picture out and put it in our notebook when we get there. So we're not going to try to draw that picture here. S waves are a little bit different. S waves don't go through liquid. So they can't pass through the outer core. And in fact, this is how we know that the outer core is a liquid, because we look at where the S waves come out on the other side of the Earth, and there is a shadow zone for S waves as well, and that tells us, kind of through a little bit of backtracking, where those waves have been and where they haven't been. And the S wave shadow zone is bigger than the P wave shadow zone. There's a larger space on the other side of the planet where the S waves don't come out because they can't pass through the core, and so they bend around the core and they come out at different places that way. Last bit of information from this section was about the speed of seismic waves in respect to the temperature of what they're traveling through. So seismic waves slow down as the temperature goes up. Seismic waves get slower where the temperatures are higher. So seismic waves can be used to visualize structures like slabs also known as slab pull. We talked about that back in the plate tectonics chapter. And plumes, aka also known as hot spots. And we talked about that during the volcano chapter. Okay, that should do it for today's notes. Stay tuned for tomorrow.